Dominique and Flavio, for your operator's perspective. I must explain now that I am a last-minute stand-in for Mr. Bill St. Arnaud, the Chief Technology Officer, or sorry, the Chief Executive Officer of CANARI, the Canadian Internet Research Organization, who was to be the session chair. It is because of that then that I have both a presentation myself and also I am doing the duties of session chair. Therefore, I get to introduce myself as the last speaker in our session. Recall that I told you at the beginning that I am chairman of the ICT Standards Advisory Council of Canada, and I want to bring you now some perspectives from the membership of what is called ISAC. A moment of introduction. ISAC is an industry government initiative founded in 1991. Our mission is to recommend standard strategies both for domestic and international ICT standards development. We have a wide variety of membership in Canada, including some accredited SDOs, domestic SDOs in Canada, industry associations, private sector companies such as Nortel, the one that I am employed by, and a number of government departments, particularly Industry Canada, which holds the brief for ICT policy and spectrum regulation. I'm afraid it's very faint, but you can see the web indicated there, the web address, and I would encourage you to visit that if you want more detail on some of the presentations that I'm going to review. What we do in our plenaries is that we provide a forum to bridge among our memberships in order to bring together standard stakeholders, the government and the users. Consistent with our interest in environment, we develop strategies for ICT standardization in Canada, but ISAC is not itself an SDO. And as Mr. Inouye has already indicated, we are the Canadian participant in the Global Standards Collaboration Round, along with some of the others represented here today, such as ETSI and TTC and ITU. We had a plenary, our most recent plenary, on the 29th of January. We undertake themes for our plenary, and in particular, the theme that we undertook on our January 29th meeting was ICT and the environment. This is slightly different than ICT and climate change, and Mr. Inouye has already pointed out that I made an intervention in Global Standards Collaboration to have the scope of that group's investigations broadened slightly to environment rather than simply climate change. We had a number of speakers on January the 29th, Industry Canada, the Electronic Product Stewardship Canada organization, Triacta Power Technologies representing smart metering, CANARI, Mr. Bill St. Arnaud's organization, Saving the Planet at the Speed of Light, and I have seen that other presentations with very similar titles, so there's people have been reading each other's presentations. And finally, we had a presentation from the IEEE 802.3AZ on their energy efficient Ethernet initiative. And as I say, the presentations from each of these participants are on the website. Industry Canada brought a number of perspectives to our meeting. And one of the disadvantages of speaking at this point in the agenda, after many speakers have already spoken, is that many of the thoughts that I might have wished to dwell on have already been dwelt on by others. So I won't do that again. Suffice it to say that Industry Canada does share many of the same concerns that we have already heard. A conviction that ICTs can improve environmental monitoring through sensor networks and remote monitoring. ICTs can aid in natural disasters to bring advanced detection and public warning. ICTs can help air pollution, the thought that we heard this morning from Sean Kidney from Australia. The promotion of teleworking to reduce commuting, and the telehealth application to reduce the travel from remote locations, which thought we heard from the Fibre to the Home Council this morning. I would only add that in Canada, of course, with our geography, we have a lot of rural and remote locations, and that is particularly important to us. Other thoughts on intelligent transportation system, as we have already heard, that also is recognized, and Canada supports the use of intelligent transportation systems as well. E-commerce, dematerialization, many of the themes that we have heard. And Industry Canada is of the opinion that standards will play a key role as we go forward. Standards for environmental monitoring, for managing electronic product lifecycle, more about that in a minute. For radio spectrum harmonization, as we heard yesterday from the ITUR, and the use of telecoms for disaster relief and emergency services. I have a few slides on, particularly on electronic product recycling. Power metering has been mentioned. It's unfortunate perhaps that since it didn't get a lot of play at this session, I might have chosen more slides or some slides from that presentation. Suffice it to say that there's an active growing industry in Canada for smart metering in order to assist with load leveling that we have already heard of. In particular, though, let me make just a very few remarks on two things, power requirements, reduction of power requirements, and on end-life recycling of ICT products. E-waste, and this speaks to the difference between strictly the climate change agenda and the environmental agenda. E-waste is an environmental problem that needs prompt action. We had found in Canada that a lot of end-of-life electronics and IT equipment was going to landfills, which has toxicity problems. Again, we heard yesterday that there is a certain fraction of any electronic product that contains hazardous materials. And there are great advantages seen in being able to recover the valuable material and also to recover the hazardous material and keep it out of environment. In Canada, an organization was founded called the Electronics Product Stewardship Canada, a non-profit organization. It was founded with large industry participation solely to work towards harmonized stewardship programs for waste electronic products. It has managed a couple of significant accomplishments just within the last couple of years. It has produced a standard for recyclers, that is to say the commercial establishments that take the products to recycle them. And a number of the key provisions of that Canadian standard are shown here, particularly enhanced requirement for environmental and health safety in the establishments themselves, prohibition of prison labor, and a strong attempt to prohibit the shipping of waste material out of the country to developing or non-OECD countries. In addition to the standard, there's also a guidance document that has been prepared, again for the recyclers, and it deals with a number of topics that you see here: material separation, substances of concern, and so on. I should add that those documents have been well received. They have been implemented within the Canadian industry. We are gaining experience with the application of both the standard and the guidance document, and it is anticipated that we would bring those to an international SDO at some point for broader exposure and international harmonization. Now let me move to the presentation, or a quick summary of the presentation that Mr. St. Arnaud from Canary gave to our ISAC plenary, which dealt with some concepts on future internet architectures and protocols. Canary is of the strong opinion that incremental efficiency improvements of a few percent here and a few percent there are not really what we're after, that Canary position is that radical changes in internet architecture and applications are needed. We need to target a zero carbon network, and that means some significant changes to the architecture and to the elements that are used. One point in particular, which we heard from Donna Young yesterday, is that many of the renewable energy sites are in remote locations, and it's often difficult then to bring the power onto the grid. There is another option, and that is then to disperse the data centers to the remote locations and rely on optical connectivity, which is a very power efficient methodology in order to take advantage of the remote sites for renewable energy sources. Canada is in, I think, a good position for that. If we put some data centers in the cooler parts of the country, we could then take advantage of another concept that we have heard, which is fresh air cooling. Other circumpolar countries have proposed similar strategies. Canary has proposed some continuing research activities in order to advance the possibility for such networks. As you see here, brand new architectures and new measurements as well. The concept of bits per carbon utilization and carbon optimized routing tables and so on. And Canary, I think, is still in early stages in developing their architectures. Now this is the takeaway slide. It's a term I've picked up from some other speakers, a very handy term. Canary undoubtedly will continue with their architectures and their future work. But in the short term, there's one particular thing that ISAC has settled on as a low-hanging fruit work activity that could be undertaken, and that is the idea of a measure of value, a metric. We've heard the word metric used a number of times yesterday and today to mean quite a few different things. What I mean for it here is some measure of value of power consumption. And our point here is that it's not as simple as it may seem. We've heard a lot of talk about energy consumption measured in kilowatt hours or megawatt hours. But if you want to get a measure of value to use in comparing one implementation against another, I think you have to normalize that somehow as power per bit, or perhaps per line, or per subscriber, or some combination of the above. You need to take into consideration the busy values versus idle values. You need to think about whether you could do this on a network element basis or on an end-to-end application. Do you want to make an instantaneous measure or a time-integrated measure? And if you can solve all of those problems and come down to a decision on a metric, then there is the issue of test specification. How would you then measure it? And then, of course, having done all that, that still does not address the issue of what would be a good number. Would 5 be a good number, or would 12 be a good number? What actually constitutes a number that we could be proud of once we decide on how and what we're going to measure? And the second point is that our success with recycling suggests that there is an opportunity internationally to harmonize recycling standards. We've certainly heard that the European Commission has taken a leading role, and I think that internationally we can anticipate that every jurisdiction will soon come forward with some recycling regulation or standard, and there is an opportunity then that, in our view, for some harmonization, some global harmonization for both the recycling standard and for a very similar, closely related topic, which is the disclosure standards. How actually do you tell what materials are included in the products that are being recycled? I was surprised to discover upon investigation that even the naming conventions are not uniform, whether there are commercial names used or chemical names used. There's no clear convention on how to do that, or on other things such as what threshold amounts must there be before a particular substance is declared, and what are the units of measure, and so on. So those are some simple things I think that the SDO community could address in order to get some early hits. Thank you. That brings me to the close of my prepared remarks. And I'm afraid we are slightly over. What is your advice on questions? Do you